friends, how are you all today? Have you ever wondered what embedded systems are and how they are being used in the current technology? It's coming up right now. I'm Prashant. I'm a technical trainer and freelancer in Dhaarini Academy of Technical Education, Bengaluru. We'll start with the concepts of embedded systems now.
The classification classification of embedded systems. Now, so based on a lot of different criteria, we can classify the embedded systems. Okay. Now, but before we go for variety of parameters deciding the classification, we'll go with the simple ones first. Okay. The first category, first classification is based on the generation. Generation based. Okay, first category is generation based. So the initial ones we call as first generation, then after some time some modifications we call second generation, and third and fourth and so on. Okay, right? So the first category is called as the first generation. Okay, this is generation. Normally 1G is the standard notation for that. So in the first generation, what are the features? Let's see. So normally this generation was based on simple microprocessors like 8-bit or 4-bit, smallest in size. Okay, so what is the first feature we can write? Either you are using a 8-bit microprocessor or 4-bit microcontroller. Right, were used. Right, what do you mean by this 8-bit? 8-bit means what is this 4-bit? So that is actually the data size it can handle, right? So if you are going to give a input data, say maybe you are giving an input data as 12. Okay, this 12 will be converted into a 8-bit data format. Okay, we know that all the computers are familiar with the zeros and ones, right? So the 12 can, maybe you convert the 12 into 0001 and 0010. So this corresponds to the 2, this corresponds to 1. So you see, right, you are using the 8 bits for representation of any data that is given as input or the output. So the processor is capable of handling 8 bits of data at a time. Okay, or maybe another version is 4-bit microcontroller. You can give 4 bits of data at a time. Okay, either of them were used. So other feature includes, like, they are using very simple hardware circuits. Okay, so I'll write hardware circuits are very simple, right? No complicated design. Then what is a software? I should be able to talk about the software as well, because I am dealing with an embedded system, right? So That means the hardware circuit that you are using here is simple, means you should not be able to uh, put very complicated programs over there, right? It's not possible. So what you use simple assembly level code. All right, so assembly code is used for the development programs, or maybe the OS, embedded OS. Okay, so then let's go for some examples, some simple examples which were belonging to the first generation. Okay, this is digital, uh, maybe keypads, and maybe simple stepper motors, etc. are the best example for this, for the first generation embedded systems. Then now let's go to the second generation. Now the second generation has a feature like either you are using 16-bit microprocessor, or you are going to use 8-bit microcontrollers. Okay, you are using either of them, right? Now they're not very powerful, but they're not as simple as the first generation. Okay, so I'll write more complex first generation. Okay, so directly I'll go for examples, right? You have uh, some hardwares which perform the conversion of an analog signal into digital signal. So they are called as ADCs, analog to digital converters, or the DAC, digital to analog converters, right? All these are the second generation systems. Okay, they are basically the data acquisition system, right? Some temperature signal is coming for it. You are measuring the temperature. These are converted into digital values, like you are going to get the samples. Okay, so this is a continuous in time, this is discrete in time. So you are converting from analog into digital, okay, or the vice versa, digital to analog, right? Those systems are the second generation embedded devices. Okay, let's go ahead. Now the third generation comes in the picture. Right. So now here the characteristics are either you use the 32-bit microprocessors, or you may use 16-bit microcontrollers. 16-bit microcontrollers. Right. Now, this is the generation which brought domain-specific processors and the controllers. So, in the first and second generation, the there were no domain specific processors or the controllers. For example, there is a specific set of uh, processors or controllers. They are designed for microwave oven, which you don't use inside a washing machine. You have specific, right, processors and controllers like that. Those concepts were built in the third generation. Okay, third onwards, you see the domain specific hardware, right? So that's it's a specific feature of the third generation case. All right, so this is domain specific uh, processors or controllers, right? Um, Used. So the major application of the third generation, right, resulted in, right, robotics, right. Robots were by using the concepts of the third generation. All right. Then the most recent one is the fourth generation. Fourth generation embedded system, which we are going to use or we are using in some of the formats. So they use 64-bit, okay, 64-bit processors, or they use 32-bit, right, controllers. Okay, this is one feature. Then is, now we have some concepts which are called as the system on chips, the multi-core processors, etc. All those designs are the features of fourth generation embedded system. Okay, so advanced, I'll write advanced designs include the following. So what we are including, the first one is called as the system on chips. System on system on chips. Then we have the multi-core processors. Okay, so we have these advanced things coming up in case of the fourth generation. So these systems are highly complex, but they are very powerful in nature. So looking at the examples of the fourth generation, right? Smartphones, and maybe the handheld internet devices we called as a mobile internet devices. So they are just examples of fourth generation embedded systems. Okay, this is the first category. The second category is based on the performance or maybe it is complexity based. Alright, so based on this, we can still classify, right, the embedded systems. Okay, under this category, the first class is called as the small scale embedded systems. Alright, so the small scale embedded systems are normally small in terms of its operating capabilities, right? So when we say small, we should have a little hardware, uh, a simple software, not a complex hardware, right? And maybe some simple board level design should be included in that. Okay, so let's write the features directly below this, right? So it should be using a single, right? You may use 8-bit or a 16-bit uh, controller. Controller in the sense you can use a microprocessor, microcontroller, anything, right? Then simple hardwares, other components, they should be simple, and the simple softwares, right? This is what should be included. Complexity should be very less, and we are expecting simple board level design in the sense you use a single board where you design, right, the various components, they are present on the same board. Okay, we call it as a board level design, right? These are the basic features. Now you will write the codes normally in assembly, right? So whenever you use assembly, right, you have an editor to write the code. There will be an assembler which converts your code into the binary format or the machine readable format, right? And an execution part. Okay, so which executes your uh, embedded system. And since this is a small scale, right, you should be able to operate this by using simple batteries, right? No power requirements, like no AC power requirements. Simply put some batteries and this should work. Okay, so we are expecting it to be very simple. That's why this is a battery operated power supply. Okay, so the small scale works on these principles. Okay, let's go further. The next case, that is second category. This is the medium scale. When it comes to the medium scale, now these embedded systems are designed with, right, single or more. You can have multiple controllers also, right, with a either 16-bit or 32 bits. All right, so we'll write that 32-bit, right? You can see single or multiple. In the sense, on the same design, you can use multiple microprocessors, multiple microcontrollers, right? But it's not limited to that. You can actually go ahead and use a RISC machine, reduced instruction set, or some other special types of devices called DSPs, digital signal processors. So the processors are of variety. We have a lot of types of computing devices available in the market, out of which you can use any of them, right? Previously, you were supposed to use only simple devices like simple controllers only. But now you can go ahead and use what do you wrote? Okay, 16 or 32-bit single, multiple microcontrollers, or you can use risk machine. They are separate types of advanced computing device, or you can also use much advanced devices such as DSPs. You can use any of them, single or multiple. See, that's why this is the medium scale. Okay, then they use complex softwares to program. You may use programming languages such as C, C++, Java, okay, RTOS, right, etc. That's why this belongs to the medium scale. Then we go to the third case. This is called as sophisticated embedded systems. Okay, so these sophisticated embedded systems have, right, massive hardwares and softwares. So they are very powerful, and definitely they are very costly. Okay, but they are powerful. They save a lot of time. They are very fast. Okay, so here the feature is that one very important feature is that you will be able to configure, right? So their feature includes scalability. So they are scalable and reconfigurable. Okay, this is the very basic feature, right? Maybe you are going to use them in flight landing systems, okay, military applications, right? These we have not used so far. This, let me write an example. Okay, so uh, flight landing systems, flight landing system, and also maybe military applications. Okay, so based on the capability, right, we are able to divide or classify the embedded system into these three classes. Next, we are going to see the major application areas of embedded systems. So first one is automobiles. Automobiles and telecommunication. I'll club two to make a single category. Okay, automobiles and telecommunication. Okay, so in case of automobile and telecommunication, right, we are going to use it thing in car motor control. Okay, that's also you will use in the engine safety. Then entertainment system of your vehicle. Okay, maybe you use in robotics. You also use it in the wireless communication. Okay, wireless communication devices, and you use in mobile. We call it as a mobile computing and networking. Okay, first category based on the application, right? Then the second is club smart cards. I use defense and satellite. Okay, smart cards, defense, satellite system. If you want to use it here, the applications could be first one is the security. Security system. Then defense, aerospace. Okay, then you use in the missile technology, and satellites are used for communication. Then the third application area is computer peripherals. Computers, and okay, here we use in computer displays, or you can call monitor. You use computer networking devices. You use in scanners or the camera, etc. So they belong to a category called image processing. Okay, then in order to get something printed out, you need a printer, right? So you use them in printers. Also, you use in specific network hardwares called network cards. Then The fourth major application comes in terms of the consumer electronics, right? Few examples will write digital camera, set top box. Okay, we will go for the 4K television, etc. Okay, these are the four major application wise, right? The classification of the embedded systems. And now we'll look into another concept. This is called as what are the purpose. Okay, so purpose of embedded systems. In the sense, what are the applications based on what categories you can use. So maybe the first one we can call, you use embedded system for data collection, or you may want it to use it for storage, or you may want to use it for representation of the data. Okay, so either you want to collect the data, which basically performs the data acquisition. Okay, so data acquisition, right? Like a scanner, or or you want to take a photograph, etc., the collection of data, right? Then you want to use it for the storage, right? Storage in the sense, right, you collect some information in the form of a signal. That signal needs to be stored somewhere, right? You may use it, right, for a in the form of a memory, right? We have variety of memory available, right? uh, memories are basically designed what type of data you want to store, right? According to that, you have a variety of options available. Using the embedded systems, you can collect the data. Okay, so already I mentioned one thing, that is analog to digital converters, right? There are several devices which convert your signals. So maybe you have to use a converter before you store it. Okay, data acquisition is collection. Now when it comes to the storage, right, you may need to convert the data before you store. So I just write the data conversion and storage. Okay, this is the second thing, right, coming under this category. And the collected data, after you store, right, maybe you want this to be shown somewhere. Representation in the sense, I have a LCD display where I want to store what images I have. Okay, so that's what is a representation. You can show it, right, represent it on screens, represent it, maybe you attach it to a mail and you send it. That's also a representation. Okay, so representation basically is display or attach to mail, etc. This falls under this category. Okay, the first one. Now I'll go to the second one. This is the data communication. All right. Now, embedded communication systems like networking systems are used to send the data over some medium from one place to other place. Okay. So this basically uses transmission of data over a medium, right? So what are the various embedded tools we use to transmit? If you remember, we can use, these are the examples like Bluetooth, right? Bluetooth. Maybe you can use, this is older technique, the Zigbee networks. Nowadays we are very familiar with the Wi-Fi systems, etc. Okay, so we use these kind of systems for the communication. The third is data processing. Okay, this is data processing systems. Now, in the data processing, embedded systems with, say, signal processing capabilities. In the sense, you have taken a picture, you want to improve the clarity of the picture, increase the contrast, right? Reduce the blurriness, right? Or remove noise, right? All these things are done after you have the photo with you or the data with you, and you process it somehow to improve the information content. Okay, so that is what comes under this. Again, you need to have a specific hardware and software to support this. So this is to increase the information content of the collected data. Sorry. All right, content of data. All right, so you try to improve this. So specific hardware and software are required for this, right? Any general device may not be able to do this job. So example, we need to have a specific software to edit your image, right? So or the video. So that is present. Normally it is always directly present inside the camera will have that. I can simply do a drag drop or something like that. Some simple operations will help you to improve the quality of the image which you have, right, taken. All right, that's the case. The next category is monitoring. For example, you want to keep something uh, under monitor. Okay, in the sense of say medical equipments, right? They are normally having a display to monitor several uh, parameters of the patient. Maybe you are connecting something so that you monitor the heartbeat, ECG. Something else is connected to monitor the pressure, blood pressure. Something else is being displayed, which is the temperature, etc. Correct. So you see that the monitoring system is used to continuously monitor some data. So, to monitor the data, right? Under this category, we can see the CROs, cathode ray oscilloscope. You can also use the multimeters. Okay, and in labs we might have seen the logical analyzers, etc. All those things are again the embedded systems, but they fall under this particular purpose of embedded system. You try to monitor something. Okay, then the fifth category is the control. Right? Any sensor or any kind of actuators will be following under this category. Okay, so sensors and actuators. Right? So what is a sensor? Sensor is the one which senses an environmental variable. Okay, example, you want to measure, uh, you want to build a system which keeps monitoring of temperature, pressure at some location. Okay, so the temperature will be sensed by a sensor. Okay. Now, what is an actuator? Actuator is, right, you want to take some action based on the sensed value. For example, you want to design a fire extinguisher system. So, fire is detected by a sensor, but when the fire is detected, what action you want to take, right? Maybe you want to start spraying water, right? The device which starts spraying the water is actuator. Okay, so sensors and actuators are, right, coming under this category. Right, sensor captures the environmental variable and the actuator will change something depending upon the value sensed by the sensor. Okay, good example is maybe I can give the automatic AC, right? You will set the value to 25, but if the temperature is continuously monitored by the temperature sensor, says temperature is less than 25, or sorry, more than 25, right? What happens? The fans will automatically turn on and make the temperature to 25. Once it reaches 25, it shuts off the fans. Okay, but if the temperature is below 25, right, you see that the fans will never turn on because temperature is below that. You set a value which is 25. Okay, only when the temperature is more than 25 it will automatically brings it down to the that value. Okay, so I'll just write what is a sensor. So sensor is used to measure any environmental variable. Right, at the same time, the actuator takes some action based on this input measured by the sensor. Fine. The next category is application specific circuits. So we call it by a name, that is ASIC, application specific integrated circuit of the category, because this will be always in the form of a chip. You get a specific IC, right, for specific application. Right, so what are the features? The features include high performance applications are normally they depend on smaller circuits. I cannot make my system very big whenever I want to go for a very highly complicated application. So, right? So what you do, you design the ICs, right? That is integrated circuits for high performance applications. High performance applications. Right now, in order to reduce the cost, always we go for the IC type of integrated circuit manufacturing. We'll go for that. That is always suggested because that reduces the cost by a huge margin. Okay, and also it takes very less space, right? Because of all these reasons, we go for the application specific circuits.
That's all for the day. Feel free to contact if you have any doubts related to any topics in engineering. We can also help you in solving your assignments, projects, and many more. Thanks for watching. Good day.